Okay, so today we're going to talk about how to deal with the different types of glassware that we're going to use in the density and accuracy lab. Okay, so I'm going to give a quick demonstration of each. So the first one we're going to talk about is a beaker. They have a little lip at the top, pretty common stuff. We measure stuff in them all the time. This is a 150 ml beaker. What this means is if you fill it all the way to the top, it should be around 150 mils. The scale on the side is not super accurate. It even says approximate volumes. So if you need about 100 mils, if you put it right on that line, it's going to be plus or minus 10, maybe. It'll be pretty close, but it is definitely not very precise. Okay. A lot of times when we need to measure volumes, the easiest thing to do is to use a graduated cylinder. Okay. First of all, this little yellow thing here, it's supposed to be at the top. It's literally there so that if the thing falls over, it will keep it from shattering the glass. It is not to be used with measuring. I see a lot of students do that. It's totally not the right answer. In terms of measuring this though, what you want to do is you want to get this to eye level, because what happens is the water sticks to the side. Okay, you see the water's in there? The water sticks to the side, and so the way this is supposed to be set up is you're supposed to read it from the bottom of the bubble. It's called a meniscus. Okay, it looks like an upside down bubble. I need to move the camera here so we can do this. These are supposed to be read to 1 decimal place, so plus or minus 0.1. So in terms of reading this here, this would be 15, 16, 17, 18, 19, 20. Okay, we can see the markings in there. So this should be a little above, it's between 15 and 16. You can kind of eyeball it to, I'd say, about 15.6, 15.7. It's not super accurate, but it's not terrible, okay? It's way more accurate than the beaker over here, okay? So we read it to 1 decimal place. The next option we need to deal with is something called a burette. They are really tall and skinny and kind of a pain. And the way they work is they have a little valve down here, and when you open it, it releases it opens it up so that it can release it and drip stuff in there. We use it a lot for titrations, which you probably haven't got to in lecture yet, but you will soon. These ones also read from the bottom of the meniscus, but you'll notice this has a lot more markings on it. Okay, you'll also notice the numbers get bigger as you go from top to bottom, because it's designed to measure how much you're dispensing. So this is going 35, 36, 37, 38. You're not measuring how much is in here, you're measuring how much you're dispensing in the process. So what you would do is you would record the initial value, dispense some, and then record the final value. The difference between those would be how much you released. Okay, if you're trying to read this, you want to get this at eye level, and I'd say it's 34. This gets 2 decimals, so 34.3. So, sorry, I'm trying to use a camera and do this at the same time. So, sorry, 35.1, 0.2, 0.3, 0.4. So it's 35.37, 35.38 maybe. The last number is going to have a little bit of wiggle room to it, and that's okay. You just do the best you can and understand that if somebody else came along and read it, it might be a little bit different. But that last digit is the only one we have to guesstimate on. Okay. The next piece of equipment we're going to use is something called a pipette. Okay. I don't know how I'm going to do this with one hand, but we'll figure it out. The way this works is this measures up to 5 mils. It starts at 0 at the top, and it's designed to dispense whatever amount that you start with, or whatever amount that it's designed to deliver a specific amount. These are accurate to plus or minus 0.01 also. So we see that we have increments between, so it's 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, whatever, all the way up to 1. And then for each unit, there's 10 in between. And the idea is we would take this thing, put it on the top. See if I can do this with one hand. And the way this works is it has this thing at the top, and when you put it into liquid, when you roll this up, it will suck liquid up the top, or out of the bottom, sorry, up to the top. And then you can read where it's at. And so, same as a burette, basically, sorry, trying to get this to focus. This is about 0.85, 0.88, somewhere in that range. And then what you would do is there is a little release valve. When you push it, it will allow this to release. Sorry, it's tapping against the glass. So what you would do is you would basically record your initial value. Then when you let go, or when you let go, so you release it, and when you let go, it goes down to, let's say this is 1.93. The difference would be how much you dispensed into the container. Okay. If you want to release it all, you just let go and it'll, or squeeze it and it'll let go of all of it. Okay. Not a huge deal. They're a little finicky, but they just takes a little trial and error to get good at them. But they're not horribly difficult to use. Okay. The last option that we're going to talk about are balances. We use these all the time. We have fairly good, fairly precise balances in here. They measure to 3 decimal places. Okay. So this is actually pretty air sensitive. If I blow on it, which you'll have a mask on, it won't happen, but you can see the numbers fluctuate around. So what you want to do is make sure this is closed. Hit the 0 button, the 0/T. T stands for tare. This one's already been 0, but I'm going to do it again. Okay, give it a second to make sure it reads 0.00. Then you're going to measure whatever you have in here. Right now I have a pair of tweezers. Okay, you're going to leave it set, close this lid, and you'll notice the last digit sometimes fluctuates a little bit. Let it settle, make sure it's done fluctuating. There, it's jumping back between the 3 and the 2. So the answer here would be 18.95, looking like it's stabilizing on 3. And so that would be the match you get. But you get 5 sig figs with this. This one's a very precise piece of equipment. The more decimals you have, the more expensive these balances are, but this one's pretty good. Okay? All right. Thank you.